All right, today we're going to be working section 5.3, functions and relations. So number one, we want to write a set of ordered pairs, x and y, for the relation that we're given. We're going to write the domain, the range, and determine if the relation defines y as a function of x. And so if we look at these ordered pairs, we're just going to list the ordered pairs. -1 in the x direction, -3. So I'm going to write them all down first. So we got -1, -3. And then I'm going from left to right, so I'm just going to list them left to right. So the next one we have at the origin, which is going to be 0, 0. Next one we have 2, 4. And then we have 2 points on the x value of 3. That is 3, 1 and 3, 4. Okay. So these are the ordered pairs that we're pulling off of this graph, these ordered pairs, and we're going to input them here. So each time I'll just click the ordered pair box, -1, -3. Separate each of them with a comma. 0, 0. Add a comma. 2. I need a comma there. 4. There we have it. 3, 1. And 3, 4. Okay. -1, 3, 0, 0, 2 and 4, 3 and 1, and 3 and 4. Don't forget to write your answer in set notation. Do we need to put this in a curly bracket? Okay, so I want you to write it in set notation, put curly brackets around each of those ordered pairs, or not each of them, the whole set of ordered pairs. The domain, okay, we're going to list that as a set. So the domain is referring to the x values only, the first coordinate. Okay, so the domain is going to be all the x values. So usually when I'm writing domain, I'll write a D with colon and curly bracket. I'm going to list all of the first coordinate values. So -1, 0, 2, 3. Now 3 shows up again, but you do not repeat it. The domain is only wanting to know all of the values associated on the graph that actually have an x value associated with the y value. So even though there's 5 ordered pairs, one of them repeats, you don't need to list it twice. Okay. So -1, 0, 2, and 3. So only the first coordinate or the x coordinates. The range is the set of y coordinates. So I would do the same thing. I'll list all the y values. Now you can list them numerically, but they're not going to be in numerical order if you just go left to right the way you listed the x values. So we get -3, 0. Actually, they kind of look like they do almost, except when we get here. So 4, 1. And then we get 4 again. You don't have to repeat it. Now you can put them in order. It doesn't matter. Just make sure you want to get all the values, unless it specifically says to put them in order. And then now the last part says the relation is or is not a function. So how do we know if it's a function? Well, when we look at the graph, if the x value repeats, it's not a function. Okay. This is the same as the vertical line test. So if we were to draw a vertical line, the line should only cross through one point. If any vertical line goes through 2 points, that's the same as the x value repeating. So right here, the repetition of 3 as a x coordinate and being paired with 2 different y values, that is a problem. Okay. Even though the y value repeats, you can see that there are 2 4s. Okay, that's okay. That's a different test. But for right now, for a vertical line test, that's going to be the 2 3s repeating. And so if x repeats, it's not a function. If it fails the vertical line test, that means there's 2 x values on the same vertical line that gives you 2 different outputs. So this is not a function.